This is a step-by-step tutorial that's going to teach you how to read a wiring diagram and correct the mistakes, the errors that are always in the wiring diagram, and then allow you to troubleshoot and find the problems that you've got with your wiring, which is presumably why you're looking at this video. It's not going to take 3 minutes because there's a lot of issues to talk about, so grab a beer or a pot of tea and let's get started. Okay, so this is a wiring diagram for an MX50, and it's fairly typical for motorcycles, and we need to have some method to follow through the wiring. So we're going to look at the battery first. There is a generator as well, so there's going to be two circuits, and so it's going to be easier if you highlight the particular circuits. So a good way would be to print off this wiring diagram, a hard copy, and then with a highlighter pen you can highlight the different cables. Now I've already started this, and we'll continue through and you'll see how to do it. Here we've made a start, and we've got the battery here. I'm going to look at the battery first, and we've got the earth marked off here in blue. This is the neutral, and this is going to go to the frame of the bike or the chassis of the car. So the power is delivered to the components, and then it always is returned and ultimately connects to the chassis or the frame. We'll follow the power from the battery. So as we come up here, and we've highlighted this, and we get to this box here. Now it's marked as fuse 7.5 amps, and it's got a number 5, and so we can look at number 5, and it's called fuses, which is a little bit confusing because there's this arrow here and a bar. And we'll look at that later, but that's a non-return valve and it's coming from the generator, and so we're going to concentrate on the battery circuit first. So we can see that the power comes through this fuse and passes through a connector. So there's going to be a physical connector in your wiring loom, and comes up and across and up through another connector block here. And you can see there's no, it's not showing a connection, but we know that this goes straight through these boxes and up to this, what we can see is going to be a switch, and it's marked 15. And 15 is the key operated switch. Okay, so what we can see is that this, with the key out, this would be open. There's no contact between these, so it would be normally open, and when the key is in and turned, the power will flow across to this connection here. So let's see where it goes. So let's just mark it here and bring it down, and it comes to a connection here and across. We'll draw that in here. We're going to be looking primarily that it's going here and to 14. So let's have a look at 14. Blinking. So it's the blinker. this is a blinker unit that is going to control the blinking of the indicators, the direction indicators. So it's directly going to be receiving power, and then it's going to come out from here and come across here. And it's going to go up through this connector block to these switches here. If you push the left indicator, then it will put power to this terminal. If you push the right indicator, it will push power to this terminal. Okay, so let's see where it goes. It's coming down here and then across here, and also here, so we'll draw that in. Okay, so that's coming from this left indicator. So we imagine this is going to go to an indicator light. We'll draw that in. Okay, so here we have it, 12. We're going to look and see what's 12. 12 is the rear light. Well, that just doesn't make sense. We're looking for an indicator, not a rear light. And from the diagram we can see there's a lamp here and a lamp here. Likely indicators, and here in the middle is going to be the rear light. And we can see that it's marked 12 and 12. So that's our first error. And we're absolutely certain, because this is coming from the indicator switch. So you just got to have the courage of your conviction and cross out the 2 and mark it in with a 1, because here we can see 11 rear left direction indicator. So that should be 11. 12 is the rear light, 13 is the other indicator. Alright? Okay, now let's just, before we look at the running back to earth, to the frame, let's follow across. Now, if that's the rear, we expect this to be the front indicator. We can draw it in. Okay. 28. Front left direction indicator, so that's okay. Okay, before we look at the return path, you can notice that there is a connection here running up. So let's draw that in. Okay, and we presume that this is going to be something, a feedback lamp that's going to tell us that the indicator lights are on. Okay, so it's in block 18 and we're looking at 20. Block 18, complete dashboard. 20, direction indicator warning light. All that makes sense. This is a light. We know that if the power is being used, there's going to be a connection to earth. It's going to run back to earth, and perhaps it's that, but let's just follow the earth now, because we've got our entire indicator circuit for the left turn. So here we have the return flow. And here you can see this circuit is going to come down to earth here, so it's returning here. Now there's also an earth circuit. We'll draw this line in. This is all earth return. it's coming here. So this lamp is being powered, and then it's coming back down to the chassis. Yeah. And here, if we look at this other indicator here, damn, can't draw it in. That'll do. Okay. Here we have the earth return on the same cable coming back down to earth. Okay, so let's just now look at the right indicator and just confirm the same. So we'll connect and we'll bring it down to here and go across here. And there we are, we can see that 25 is going to be the right indicator, front right direction indicator, and we're here to 13. Which is the rear right indicator, as we're going to know. Rear right direction indicator, and it's always worth checking that just to confirm in case you need to modify any of the numbers. And here we have our return, so that's coming back down to the same earth cable here, and similarly here the same cable. Let's just follow through on the earth of our indicator lamp on the dashboard, and we have our power coming in here, and perhaps this is the earth cable coming down here, so we follow it down, but no, this is the power feed from the right indicator. So this is showing that this lamp illuminates from either the left indicator or the right indicator. So where's the earth? Well, they forgot to show it. You know, it's just how it is. So yeah, let's just draw it in, you know. That'll do. So now we have our earth. We have our two feeds coming in from the left and the right, and we have an earth. At least that makes sense. Yeah, cool. So that, in fact, we have identified the direction indicators, and we've done that by simply following the circuit from the battery. Now, if you were doing this on the computer, you could just simply save that and label that as the direction indicator circuit, and you will be able to follow it through and see where there are connectors and have a good idea as to what's going on. And what we're going to do now is we're going to continue looking and see what other faults we find, and yeah, let's move forward. Okay, so we've saved the direction indicator image, and we're starting again now. And the power from the battery through the fuse up through the connector to the switch, and the key is in and it's turned and the power comes down, and this time we're going to go over here. Now we've done the indicators and it's going to come down to here. And there's a switch shown, in fact, and it's not got a number. Oh dear. So at this moment in time we don't know what this switch is, as is typical with wiring diagrams, but we do know that there's a switch and it's going to come here and here. Okay, so let's just see what happens if we follow it through. So we can go up here, okay, so there's a switch and it's coming here, and there's an S here handy, and it's coming to a light 12. Well, we already know that this is the rear light, and so we're going to guess that this is going to be with the S for the stop and the T for the tail light. This is going to be a stop switch, and it just hasn't been marked. Let's go across, because there's another connection here that's going to illuminate the stop light. So this may be a front stop switch, and this may be a rear, or vice versa. We're going to find out. Okay, so here and here. 29. Let's connect a block. Surely. 7. Let's have a look. 7. Front stoplight switch. 8. Rear stoplight switch. Now here's the 7. Here's a 9. Here's a 10. Yeah. That has to be marked up as 8. So you would need to write an 8 here, just so that you're not confused. So that we're now discovered that we are on the stoplight, and these are switches connected to the front and rear brake. Okay, so therefore the power comes through, and when we apply the brake, the switch closes. So this is a normally open switch that closes when we apply the brake. And if we apply the rear brake or the front brake, it doesn't matter, it's going to direct power to the stoplight. Okay? So let's have a look at the return. So the power is coming in, we've applied the brake, and the light lights up, and so we are here, down to earth, and yep, we're back on our earth circuit here. The same old cable. So you can see this cable is carrying all the returns to earth. And this is coming from the stoplight here. Okay, so we've saved that diagram as the stoplights wiring, and you might be thinking, well, okay, that's it, you understand, no need to continue. Well, there's so much more, and you need to know it all. So let's press ahead, and we're going to move to here. And we're now feeding the power through these connector blocks to this switch here. And this switch 17, you can see that it's to do with full beam. We've got dip here and we've got a full beam here, which is kind of weird. So this is one of those switches where it's got 3 positions, and the middle switch is dim, and at the top it's full beam, and at the bottom it's full beam, and yet they aren't connected. So that's kind of weird, and we need to understand this. So let's not confuse ourselves by looking at this. We're just aware that that this is, we're now dealing with full beam, and in this situation the power is coming to this switch here, and it's going to come down, and we follow it through the connector block to here, and hang on, go to here. And to here, and here's 16 surely it's going to be, oh, it's a front twin light, low and high beams. Okay, and we're obviously on the high beam, full beam here, and that's fine. And we can see that there's another feed coming in, and we have a feed coming off, and that looks like it's going to earth, so we might as well just draw that in. Okay, so there we have our circuit, which is fine. The power comes in from the battery, and we can feed it through and to the headlight, and it's on full beam, and then it returns back, and that's it. That's done. That's that circuit sorted, and we can save that as the battery full beam. But before we save this, let's just see what indicators we've got. Feedback in the dashboard. It's coming here. We can see there's a branch off here, coming up here. So let's mark that in. And this should be an earth coming out, we never know. And it can come down here. And yeah, it's coming to the earth, and we don't know why that's changed to there. So let's mark that. Okay, so that's better. So we now have the full circuit, including the feedback, and 21 should be high beam warning light. Okay, that's sorted. Okay, so we've saved that as the battery full beam, and we'll look at this other occurrence here of a full beam later on, you know, because it's obviously a different circuit and it's a little bit confusing. Let's just continue on with our battery, and so here we are with the keys in, it's turned, and we're here. We've done that, and we're now heading off here to the horn, and let's draw that in, And we've got something going on here. It's going directly into the dashboard, and we'll look at that later. But let's look at the horn, because this is a really weird situation. The power is going directly to the horn. Now it's coming out of the horn. Now you don't. The horn doesn't work when you switch the key. Okay. And yet it's going directly to the horn. And now it's coming out. And this is really worth understanding. Up here to the switch. So the switch is after the component. And this is called a switched neutral. So within this wiring loom of the MX50, we have switched positives, which are normal, and we've got switched neutral, which are normal, but they're mixed. And you need to know that when you're troubleshooting. If the horn is stuck on, for example, and you're looking at the switch, but in actual fact it may well be that there's this cable here is simply touching earth before it even gets to the switch. Because the power is always going to be present. It's potential power present at the horn, and the switch is after the horn, and it's a switch neutral. Got to be aware of that in your troubleshooting. Now this is a neutral, so we expect this switch to take us back to earth. So what we need to do, and it may seem bizarre, but we need to make this a neutral. Let's see where it takes us. And of course it takes us back to our earth circuit. There. And that's what's called a switched neutral. Nice. Okay, so we now have the horn circuit, and that's definitely worth a save. Alright, okay, so the horn diagram is saved, and following on from the switched neutrals, we can look here now. Oh, hang on a second. And then see where these go. Okay, so the power is coming directly to these lamps. We know there are lamps, it's part of the dashboard. 23 and 22, let's have a look, let's see what it is. Oil level warning light, neutral warning light. Okay, fine. So we've got the power coming in directly. So this is going to be the earth. So let's just see where it goes. 23. It's going to a switch 10. 10, neutral indicator. And it's to earth. This will mean that the switch is directly connected to the engine, which is also connected to the chassis. Okay, so here we have the neutral indicator, and again it's a switched neutral. And this one, switch 9, oil level sensor. So the neutral is going through a switch, it's coming back, and it's back on our earth circuit. Fine. So that's our neutral indicator and our oil light, which are also switched neutrals. We can save them as that. Right, okay, so that's the battery circuit complete, and it was worthwhile. We've corrected errors on the diagram, we've discovered switched positives, switched neutrals, and now we're going to look at the generator circuit, which is down here. And this cohabits nicely with the battery circuit. Okay, so yeah, hit pause if you need another beer or a cup of tea or something, but we're going to press ahead. Right, here we have the generator, and it's got this sine wave here indicating traditionally that it's alternating current. Either way, we don't mind. It's connected to earth, and there's 3 cables running off here to number 2. So we need to look and see what is number 2. Number 2 is the ignition coil. Okay. And this is a capacitor discharge ignition, and there is a wonderful video on YouTube. It's absolutely the best description of capacitor discharge. We don't actually have an idea of these 3 cables running to the coil. The coil will have connections that are referenced in the manual, but we don't see them in the wiring diagram. That's just how it is. We can imagine that one of these is a control that states when the spark occurs, because here, out here, this arrow here is high tension, and it's been drawn like this. Might be slightly confusing, but this is just the sign that they've used to show that this is high tension coming out of the coil, and so it will be coming in here at maybe 50 volts when you kick the bike over, and it comes out here at 10,000 volts, and it jumps across and creates a spark, and 3 should be the spark plug, as we would expect. So before we look at the generator circuits, let's just check out this cable that's running off the coil. Okay, so we have an earth cable, and the idea of the earth cable is that if you want the engine to stop, instead of jumping across the spark plug here, you feed the power directly to earth. So it comes here, 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 up to this switch. Now in this particular case, this switch is normally closed. it doesn't show it here correctly. So this one was normally open, if you remember. This one is normally closed. It means that this cable is normally connected to earth until the switch is opened with the key. So when you put the key in and you turn the key, it opens the switch, which means that this is no longer connected. So here we have it. Oh God. Running down back to our earth circuit. There we are. So when the key is not in or not turned, the earth circuit is made, right? Which means that the spark is never going to happen. The spark can only happen when you turn the key and then open this circuit, which means that this connection is no longer made, and the circuit disappears and the spark can occur. So as you see it now, this is with the key not in the ignition. So it's impossible. You can kick the engine over and it will not start. This is how it looks when the key has been turned and the earth no longer reaches earth. When the ignition is turned on, there is no connection to earth, and this allows the engine to run. And typically we can, when we're testing the bike, if there's a problem with the spark, we remove this connection here to allow the engine to run with certainty, because this is always the cable which will stop the engine from running. Yeah, okay, so I hope that's clear. So I'm going to save this diagram as engine stopped, and I'm going to save this diagram as engine running. Okay, so let's look at the remaining generator circuits. Here we've got our generator, we've dealt with the ignition and the stop circuit, so we're coming here. So let's just follow it through. To a box of tricks here. 4. Voltage regulator. Right, so this is producing power according to the revs of the engine. So the more the engine revs, the more power is produced. And we've got a feed here that's then going to go on to the rest of the circuits. And so this voltage that is being produced according to the revs of the engine now needs regulating to a voltage supply that all the bulbs can use without popping. And the whole circuit needs a regulated supply. And so this is the voltage regulator. The power comes in to this box of tricks and is regulated. And that means that the excess power that is produced is given off as heat. And so you'll see on your chassis somewhere an aluminium block of fins, and that is there simply as a heating element. It's to get rid of the electricity that we can no longer use. It takes all the excess electricity and simply burns it off as heat. It's waste, complete waste. It's just how the engines work. So we can see we've got an earth here, and we've got another earth here, and that's fine, it's clearly indicated. And when we have the power out, which is, let's see where it goes. It's coming through a connector. Right, okay, so I've come to this arrow, and there's a bar here that you might not be able to see, just there. And this is a one-way valve which allows the electricity to come through, but it doesn't go back. And if this power is greater than the power being pushed out by the battery, then this will come in and feed this circuit. So this power will arrive here and enter the battery, and in so doing it will charge the battery because it's got more power coming through. That's how it gets through. It's got more power, so it can push through and charge the battery. But also, you can notice as well, it also goes off into the battery circuits. Now this answers your question as to how it is that your bike can still perform all these tricks and features and you haven't even got a battery fitted. The voltage regulator takes the place of the battery, because here's the power coming in and going off through all the circuits that we've just previously examined. So even if you don't have a battery connected and this circuit was wiped out completely, the power would still come through here and flow through the battery circuits. And that's how the generator is combined with the battery circuits. So you don't need a battery. Everything will run fine. It's just that the engine will have to be running to generate the power to feed all these circuits. And that all happens here in this one-way valve. Okay? Now let's just see where else it goes. So it goes through this connector and then it comes back on itself. Okay, it's coming down here. And here. T to the tail light. What this means is that, and there's no switch involved. There is no switch. It's coming straight through here, down directly to the tail light. And here we've got our earth coming back here. So the tail light immediately illuminates as soon as you start the engine. There is no switch. The tail light comes on. Let's see where else it's going. Now we're back on our full beam. So we had our full beam from the battery here. which could anyway be supplied without the battery through our one-way valve. But we've also got the supply coming from the generator, comes up here through that connector, down and across, and then up to our switches here. And this is powering the full beam and the dip. So if we use the switch at the top here, then we go back down this circuit here and we then cover the circuit that we did earlier, the exact same circuit that went on down to the headlight, just the same as the battery circuit. And if we follow the dip here, it's also going to the headlight. So there's two filaments here. We've got our dip and our main beam, and we have our earth coming off that we've examined, as always, coming down to earth here. You can see how crucial this earth connection is and why you might want to keep that earth connection clean and sealed. Right, so where else is it going? And it's coming to here, and it's coming here. $27. Oh, it's 27. Front parking light. No switch. So we have a tail light and a front small light which illuminates without any switch. The moment we start the engine, these lights come on. And then here we can see the earth is connected here. Again, it's coming down to our earth. And that, I believe, is it. Oh no, we have our light up here. And what's this? Hang on. And that's 19. Let's just see what 19 is. Dashboard lamps. Oh, nice. Oh, that must be the backlight. That's the backlight that illuminates the background of the dashboard. And here we can see, does this come down to our earth? Yeah, that comes down to our earth. So that, yeah, I think that's it. Let me just check it over. Yeah, that's it. It's done. We've seen some difficulties, errors in the diagram which are typical. We've looked at all sorts of different situations of different circuits and switch neutrals, switch positives. It's not that difficult when you just work through it, circuit by circuit, cable by cable, and yeah, it should serve you well. So I think it's worth a thumbs up. I'm sorry it was a bit long, but that's wiring diagrams for you. Okay, good luck with your projects.